So now that we've completed the Quadzilla build, we'll now walk through the AutoPilot setup as well as the FlightTest parameter setup. Once you have your aircraft completed, you will then want to use the micro USB cable included with your APM 2.8 to connect to your laptop. First thing you will need to do is go to your laptop and download Mission Planner. Mission Planner can be found at planner.rdupilot.com. Now that we've downloaded Mission Planner, you will see a screen similar to this one. For the first part of our setup, we will need to go to the Initial Setup tab and click the wizard. Following these steps will walk you through getting your aircraft in the air successfully. The first thing you want to do is choose multi-rotor. Obviously our aircraft is a multi-rotor aircraft. AutoPilot will support other types of aircraft such as an aircraft, a rover, or even a helicopter. Once you've selected multi-rotor, you can then click Next. We have a standard X4 frame, so we'll click that. Select the COM port. Here you can actually see where the COM port was installed. This one we will use COM 3 as we are directly connected. You may see an issue that says the board has been retired. Mission Planner will upload the last available version to your board. Just click OK, that's alright. You must be connected to the internet for the firmware to update. Once the firmware is updated, it will automatically connect to the AutoPilot. Here you will be able to select your frame layout. Once again, we have a standard X4 frame. Once you've built your aircraft, we are now going to set up the AutoPilot. You will notice for this setup that we've removed the propellers as well as it does not have the landing gear on it. We've removed the propellers for safety reasons indoors. We don't want to take a chance on it spinning and starting up. We've removed the landing gear to aid in the initial flight test process to help eliminate any problems or any extra damage to the aircraft. The accelerometer calibration is next. All you need to do is click Start and follow the steps. You'll place the vehicle level as it sits now and press any key. Next you will place the aircraft on its left side. This is left side relative to what would be a pilot's seat, so from behind the aircraft. Once the aircraft is stable on its left side, you will press any key. You will then place the aircraft on its right side. Once again, when stable, press any key. Place the aircraft nose down, nose up, aircraft on its back. Now the calibration is successful. Once your accelerometer calibration is done, we'll move on to the next step, which is compass calibration. There's a YouTube video here that you can use that will walk you through the compass calibration, but we will also walk you through all the steps. In this step, we're going to pick up the aircraft and we will move it in essentially every attitude 360 degrees, trying to gain as many compass points as we can possibly gain. You will notice as you rotate the aircraft in various areas that there are white dots that keep appearing. The idea is to hit each of those white dots. You will gain more samples based on the attitudes the aircraft has been in. Once Mission Planner has enough data, it will let you know and you can click Done. Now that we've completed the calibration, you'll click OK and you'll see your new offsets have been saved. It's a good idea to recalibrate your compass anytime you move to a new location, as you move, your offsets would change. Next is our battery monitor configuration. For this, we are using the APM 2.5 3DR power module. For the sensor, we are using a 3DR style power module. Here you will input the size of your battery in milliamps. For today's example, we will use 4,000 milliamps. Next is radio calibration. For this, you will have needed to complete the steps to ensure your radio is bound to your receiver. Those can be found in your RC transmitter manual. So for radio calibration, you will now move the sticks in each direction to their maximum. You will notice for roll and yaw, the screen will move in the same direction as the stick. For pitch, it will go the opposite direction, and throttle, it will go the same direction. It is critical that these directions line up accordingly. You will notice channel 5, I've set it up on switch G. You can set channel 5 on any switch you would like. I personally like it on the 3-position switch. Channel 7 for me is set up on switch E. This is a very important switch for the auto-tune feature that we'll use later. Once completed, you will notice the red lines on each one that has recorded its maximum throw and minimum throw, and you will click Done. Follow the steps and click OK. And now it will display the radio setup. Click Next. Now we move on to flight modes. This is another area that you can make custom to your aircraft. For this, personally, I want to use Stabilize, Loiter, and Altitude Hold. We'll be using Altitude Hold as part of our Auto Tune feature later. You can change these to any that you want. Me personally, I'm setting this one up to where Flight Mode 1 here will be Altitude Hold. Flight Mode 4 will be Loiter, and Flight Mode 6 will be Stabilized. The other modes will not be used at this time. However, you can set your radio up any way that you would like. You'll also notice that there is a simple mode and a super simple mode on the screen. You can find more information about these in the Mission Planner help, but these are a couple of different flight modes that may assist if you are not an experienced radio control pilot. Once done, choose Complete, and we will click Next. On the next step, you will see your current progress. There are times that your compass calibration may show red here, and if it does and you've successfully completed previously, it's okay. We will not do the pre-arm test yet. That's something we want to do once we can actually see what's going on. Failsafe options. These are the different settings you can choose to enable what your aircraft will do when certain things happen, such as batteries. So if it detects your battery is low, you can choose whether you want it to land or return to launch. Land means that the aircraft will land exactly where it's at. It will just initiate a land command and will come straight down. This may not be a good thing depending on where you're at. Return to launch, RTL, means the aircraft will come back to where it was set up. That would be my recommendation. You can also choose GPS failsafe here in case you have a GPS failure. This one, altitude hold, is a good idea, and then you can manually flip it back and take control. Ground control system failure. For this, enable always return to land. This means that if you have a problem with your laptop, the aircraft will come back to where it started the flight. Throttle failsafe value you can leave at the default 975. These can be adjusted later if you'd like. Next is a geofence. Geofence is something that we will not be using today. However, you can do more research at the ArduCopter website. Here are some additional links that may give you some additional information. The ArduCopter APM wiki and ArduPilot.com are two very good resources for our entire challenge. For the next test, we want to install a battery because we want to do these tests using the radio system provided. You will now connect using the Silicon Labs USB to COM port adapter. You'll want to make sure your baud rate here is set at 57,600 and choose Connect. Now the aircraft is connected. If you're indoors, you may see a GPS no fix. This is normal. On this screen here, you will now be able to see battery voltage. Fully charged batteries will show 12.6 volts. This is your current draw. Here you will actually see your artificial horizon, including airspeed and altitude. Your compass heading up here is which direction the aircraft is flying. This is your moving map display while the aircraft is in flight. Over here, you will see the default quick displays. These can be changed at any time by simply clicking on it and choosing which of the additional features you would like to display. Our next screen is Flight Plan. On this screen, this is where you can actually pre-program waypoints for a mission. There are several different types of waypoints you can use, each of which can be found under the Mission Planner description. One very important thing to remember is that if you're going to be at a location that does not have internet, you will want to do what is called prefetching your maps. In this case, you would right-click on your screen, go down to the map tool, and choose Prefetch. Here, it will ask you what area you want to display. It's recommended to zoom in as close as you can to your necessary area to minimize the amount of data that you will need to record. The next screen we want to discuss is under your initial setup. Previously we had used the wizard. Here you can go in and adjust any of the settings we originally did in the wizard, such as frame type, accelerometer calibration, compass. You will notice here we want to use an APM with an external compass, as our compass is separate from the actual APM itself. You will only need to do this if you need to recalibrate your compass due to flying at a new location. Here we can do the radio calibration, adjust our flight modes, once again we can change these by simply modifying the locations and saving. So we will go back and do these very similar how we did before, just to show you what you can modify here. You can also go back to your flight data screen here and now flip through your various modes and watch your modes change on the screen here. You can also set your fail-safes. You can set your low batteries as well as reserve milliamps. The reserve milliamp is not very accurate, so I recommend not using that feature. For low battery, 10.5 is a good starting point and you can adjust from there.